Modernage MCQs Physics second year, unit number 15, AC circuits, part 2. Which factor is used to convert peak voltage into RMS voltage? Option A 0.107, option B 0.507, option C 0.707, option D 0.866. The key is 0.707. Therefore, the correct option is C. Reason: the RMS value of alternating voltage is 1 divided by 2 square root times the maximum voltage. Therefore, the RMS voltage is VRMS is equal to Vm divided by 2 square root, or VRMS is equal to 0.707 Vm, where Vm is the peak voltage, because 1 by 2 square root is equal to 0.707. Hence, the factor is 0.707. Which factor is used to convert root means square voltage into peak voltage? Option A 0.507, option B 0.707, option C 0.866, option D 1.414. The key is 1.414. Therefore, the correct option is D. Reason: the peak value of alternating voltage is 2 square root times the RMS voltage. Therefore, the peak voltage is Vm is equal to 2 square root into V or Ms, which is equal to 1.414 V or Ms, because 2 square root is equal to 1.414. Hence, the factor is 1.414. In a resistive circuit, the current leads the voltage by option A 90 degree, option B 60 degree, option C 30 degree, option D 0 degree. The key is 0 degree. Therefore, the correct option is D. Reason: in resistive circuit, V is equal to IR. RV is proportional to I, as R is constant at constant temperature. Therefore, when I is maximum, V is maximum, and when I is minimum, V is minimum. The current and voltage are in phase. The phase constant phi is equal to 0 degree. Hence, the current leads the voltage by 0 degree. In voltage, V is equal to Vm sine omega t of a source generates a current I is equal to Im sine omega t in. Option A, resistive circuit. Option B, capacitive circuit. Option C, inductive circuit. Option D, complex circuit. The key is resistive circuit. Therefore, the correct option is A. Reason: the wave equations of voltage V is equal to Vm sine omega t and the current I is equal to Im sine omega t are in phase. Therefore, phase constant phi is equal to 0 degree. It is the property of a resistive circuit. Hence, the voltage of a source generates a current in a resistive circuit. If an AC current I is equal to Im sine omega t through a resistor develops a potential difference of V is equal to Vm sine omega t. The power dissipation is option A IMVM, option B IMVM divided by 2, option C 2 square root IMVM, option D IMVM divided by 2 square root. The key is IMVM divided by 2. Therefore, the correct option is B. Reason: The power dissipation P is equal to average IV, which is equal to average Im sine omega t into Vm sine omega t, which can be written as Im Vm average sine square omega t, which is equal to Im Vm into 1 by 2, because the average value of sine square omega t is 1 by 2, which is equal to Im Vm divided by 2, because the average value of sine square omega t is equal to sine square theta, which is equal to 1 by 2. Hence, the power dissipation in resistor is Im Vm divided by 2. What is the power dissipation in AC resistive circuit if current through a circuit of 10 kilo ohms is 1 ampere? Option A 10 milliwatt, option B 10 kilowatt, option C 10 megawatts, option D 10 gigawatts. The key is 10 kilowatts. Therefore, the correct option is B. Reason: the power dissipation in a resistive circuit is P is equal to I square R. Therefore, power dissipation in this resistive circuit is P is equal to 1 square into 10,000, which is equal to 10,000 watt, or P is equal to 10 kilowatt. Hence, power dissipation in a resistive circuit is 10 kilowatt. A source V is equal to 20 sine 2 pi ft sends current I is equal to 10 sine 2 pi ft plus 60 to a circuit. The circuit leads voltage by option A 2 pi, option B pi, option C pi by 2, option D pi by 3. The key is pi by 3. Therefore, the correct option is D. Reason: the phase difference between voltage V and current I is phi is equal to 60 degree, or phi is equal to 180 degree divided by 3, which is equal to pi by 3. Hence, current leads the voltage by pi by 3. A source V is equal to 20 sine 2 pi ft sends current I is equal to 4 sine 2 pi ft plus 60 to a circuit. The resistance of the circuit is option A 4.0 ohms, option B 5.0 ohms, option C 10 ohms, option D 20 ohms. The key is 5.0 ohms. Therefore, the correct option is B. Reason: the resistance of the circuit by Ohm's law is R is equal to Vm divided by Im. Therefore, the resistance of the circuit is R is equal to Vm divided by Im is equal to 20 divided by 4, which is equal to 5.0 ohms. Hence, the resistance of circuit is 5.0 ohms. When a capacitor is connected to AC source, the current leads the voltage by option A 90 degree, option B 60 degree, option C 45 degree, option D 30 degree. The key is 90 degree. Therefore, the correct option is A. Reason: when an AC source of voltage V is equal to Vm sin omega t is connected with the capacitor, the charge on the plates of the capacitor increases. At any instant, the charge on plates of the capacitor is Q is equal to CV, and the current at that instant is I is equal to delta Q divided by delta T, or I is equal to delta CV divided by delta T, which is equal to delta CVM sin omega t divided by delta T, which is equal to CVM omega cos omega t, because the derivative of sin omega t is equal to omega cos omega t, which is equal to Im cos omega t plus 90 degree. Hence, current leads voltage by 90